faced with rising fax costs, a firm issued a guideline that transmissions of 10 pages or more should be sent by 2-day mail instead. Exceptions are allowed, but they want the overall average to be 10 or below. The firm examined 35 randomly chosen fax transmissions during the next year, yielding a sample mean of 14.44 with a sample standard deviation of 4.45 pages. At a 0.01 level of significance, is the true mean greater than 10? Okay, well, they're asking us to run a hypothesis test, and they're testing to see if the true mean is greater than 10. They're testing to see if there is enough evidence to prove that the true average number of pages is greater than 10. So that is going to be our alternative hypothesis. We'll assume that everything is running well and that the overall average is no more than 10. So the null and alternative hypotheses would be that mu is less than or equal to 10 for the null and that mu is greater than 10 for the alternative, and that would be our step 1. Step 2, I'm going to go ahead and create a sampling distribution, and I'm assuming that 10 is going to be in the center. The standard deviation is actually from the sample, and the sample size is 35, so I've got 4.45 over the square root of 35, and also looking at both of those, one being the sample standard deviation and 2 being 35, I'm going to go ahead and use a t-distribution for this. Also, this is an upper tail test. We're seeing if we can show that the average is above 10, so that would be on the upper end if we get a sample greater than that. And our decision line will be such that 1% of the sample averages could be above that, given that the null hypothesis is true. If I look up in the t-distribution a value for this, I'm going to be looking in column with 0.01, and in row the degrees of freedom 35 minus 1 or 34. That would give me a t-value of 2.441. So that would be my critical value for this problem. Then I will set up my rejection rule. Reject h sub 0 if the test statistic is greater than 2.441, and the test statistic will be for my sample average. How far is the 14.44 away from the 10 in standard units? Calculating the standard error, I get 0.752, so that's what I'll be dividing by. And my test statistic is 5.9. Okay, step 5 then is I am definitely going to reject h sub 0 since 5.9 is greater than 2.441. And then I can I've proven something. I rejected the null, and I'm going to go ahead and take the risk here and say that the alternative is what is true. The true average or mean number of pages that are transmitted is greater than 10. So they need to employ some sort of additional measures to try to get that average reduced to what they want, 10 or less. Now, if we consider running this test using the p-value method, it's not going to take long here to realize that the 5.9 test statistic for my 14.44 sample average is at 34 degrees of freedom is off the chart. If we look at the sampling distribution, that t-value 5.9 is going to indicate to us that our 14.44 sample average is so far to the right of our distribution here that my p-value is really essentially 0. In other words, the probability of getting anything less likely than 14.44 if the null hypothesis were true is 0. And we are more confident than ever that the null hypothesis is indeed wrong. The p-value at 0 shows the strength of our evidence, that we really have very strong evidence that the null is wrong. We were willing to take a 1% probability risk of making a type 1 error, but our risk is actually much less than that. We are even more confident that the null is indeed wrong and that we've made the right decision in rejecting it. So our chances of making a type 1 error are very small. We would write this up as 0 less than 0.01 reject H sub 0.